Hey, what's up, guys? This is Cheng here. So today, let's take a look at LeetCode number 282, expression add operators. So you're given like a string, right? Contains only digits from 0 to 9 and a target value. And you need to return all the possibilities, basically all the possibilities combination by adding only these three operators plus, minus, or multiply between the digits so that the evaluation equals to the target value. Right, so for example, the first one, we have 1, 2, 3, and we have two ways to evaluate these numbers. 1 plus 2 plus 3 equals to 6, and 1 times 2 times 3 equals to 6. Okay, here's another examples here. And yeah, so in example 3 here, as you guys can see here, so the numbers does not has to be only one digit, so it could be a multiple digits for one number. In this case, it's 10, right? Which consists of 1, 0. And here's another one, right? The basically just two zeros. So for two zeros, one thing to be noticed that 0, 0 is not a valid number. Okay, so that's why we can only split this one into two numbers. All right, cool. So and the constraint is like this. So we have, yeah, 10 to the power. Sorry, only 10 digits basically. So this one obviously is like a backtracking method, right? Where basically for each of the numbers, we try to add these three operators, right? We try all the possibilities, and then in the end, we can just evaluate that formula in the end. So for example, we have 1 here, right? I mean, for the first number, we cannot add minors, so that's why for the first number we can only add 1, right? And then for the second number here, we can add 1 plus 2, right? 1 minus 2, or 1 times 2. And same thing for number 3 here, right? So but now here we have another 3, right? We can add 3 minus 3 times 3. Similarly for this one, right? Yeah, so that's gonna be the time complexity, the brute force way. Actually, it's not a brute force way; it's a regular way. And in the end, we have like the this kind of multiple evaluations, right? And then we can just simply evaluate that formula, right? The string in the end. Of course, that one works, but that one will be a little bit slow because not only we need to construct all the formulas, but for each of the formulas we have to scan from left to right, right? To calculate to evaluate the value in the end. So can we do a little bit better, right? Can we just can we improve that so that we don't have to evaluate the entire string in the end? So the answer is yes, right? So the way we do it, we can always keep like the current values, and then in the end we just need to check the final value with the target. If they're the same, then we just add it to the final answer, right? Right. But if we want to do that, if we only have like this plus and minus operators, that would be very easy because we can simply keep adding or subtracting the numbers. But since we have this kind of multiply here, right? For example, if we have 1 plus 2 times 3, right? So if we were trying to evaluate numbers from left to right and we're having like values, right, to represent the current values, right? So of course, from 1 is 1. So 1 plus 2 will be what? Will be 3, right? Will be 3. And now, when we're at this 3 here, when we're trying to do a multiply, we cannot do a multiply of 3, right? Because that will be 9, which is the wrong answer. So instead, it should be 1 plus 2 times 6, 2 times 3, which is 7. So which means that in order to to evaluate the current values, right? We have to basically, since the current value is 3, we are by the way, we're at this digits here. The current value is 3, which means that we need to use 3 to minus 2, because we need to subtract, basically something like we pop the previous values, which means we're gonna subtract the previous values from the final result, right? And then we plus the new result, which is going to be the 2 times 3. That's how we get 7. Okay, right? So that's a plus. Similarly with minus, right? Let's say we have 1 minus 2 times 3, right? Same thing, right? So for this one, the current values will be what? So we have 1 minus 2, which is minus 1. So we also need to do the same thing. So we do a minus 1, and in this case, it's going to be a plus 2, right? And then we times plus 2 times 3, which is the uh, so this one should be minus, because we use the previous number to times multiply the current number. The previous number for the second example is minus 2. That's why we have minus 2 times 3, right? And here we are subtracting from the previously number here. That's why for this one we have 1 minus 6 is minus 5, right? So as you guys can see, so we can simply maintain a previously numbers. All we need to do is we just need to maintain a previous number here, and then we can just calculate handle this multiply case, right? So and maybe another one. So let's say we have this examples here: 1 plus 2 times 3 times 4. So how this gonna work, right? So we're at this we're at 3 here, right? And we have 3. So 3 the values will be 3. So 3 minus 2, right? We have 1, right? And then we have times plus 2 times 3, right? So after this one, right? So what's going to be the new current, or the new pre number? So this is the new pre number, because that's going to be the pre. So which we have, in this case we have 1 plus 6 equal to 7. So the current value is equal to 7, right? The value, and the current and pre will equals to 6 in this case. Okay, and now when we have like another multiply operators here, we have 4 here. So that we can use the same formula to calculate this times 4 here, right? So because we have 7, right? 7 is the value, and we subtract the pre, which is 6, right? And then we multiply what? 6 times 4, right? That's why we have 25. Yeah. So I think that's how we utilize this current the pre values, and then how can we update this pre value, right, accordingly. Yeah, and that's basically our strategy here. And another thing is that we also need to basically to handle this number which consists of multiple digits, and also this 0, 0 case here, right? Yeah, so let's start coding then. We need the backtracking, right? So backtracking here. So we need the index, we need the pre, and we need the values, right? And we need a current as. So to handle this kind of the number starting from zeros, there are like multiple ways you can do it. I mean, one of the ways is that we can we can maintain like a current values here, right? Where the it represents the what's our current numbers, so that the in the end, basically, if the index equal to n, right? So by the way, so n will be the length of numbers here, and then we have the answer equals to empty, right? And then we have backtracking in the end. So and then we return the answer, right? So to start with, we start from 0, the pre is 0, current 0, value 0, and the s is empty, right? So basically, if this one has reached the end, and if the values equals to target, right? And then we just add this append to s, append the s to the answer, right? And then we also return here. So the way we use this current is like this. So we every time we update the current by adding the current numbers to it, right? Index this one, and if the current is greater than 0, okay, if it's current than greater than 0, it means that the current digits it's not it's not 0, right? So and then we can just use the current number as part of the next numbers, right? So that we can just do this. We can do a backtracking of index plus 1. The pre is the same, current is the same, value is the same, and s is the same. So basically here I'm doing this, right? So we have 1, 2, 3, 4, 5, right? So let's say, for example, we are at 2 here, right? So since the current is greater than 0, we can simply keep everything else, and then we can move the counter to this one, which means that we're considering 223 at this moment, right? And then from here, and then we'll keep moving, considering 2, 3, 4 together, and then 2, 3, 5 together, so on and so forth, right? At each of the locations, as long as the current one is not 0, so we can just include this one as part of the current numbers, and then we keep moving forward, right? So that's that. And then now, right? So if not as, since we're going to add like this plus current numbers and then minus current numbers and then multiply current numbers, right? So if s is empty, it means that it's the first number. So for the first number, we only have one option, which is the plus, right? So that we handle this one separately. Basically, if the first one, I do this backtrack index plus 1. So the current is the current, right? And then the pre, so the pre will becomes the current, and the current becomes 0, and the values will be a value plus current, right? And the string will be the string dot current. Because here I'm not including any operators here because this number is the first number, right? Else it means that this number is not the first one, so which means that we have to consider all three scenarios. So the first one is the plus, right? So similarly with current, the previous one will be current, right? And then we have values plus current, and then we have s plus this plus sign, and then string of current. Okay, so that's the plus, and then we have a minus. So for minus, the previous one is going to be inside of current one. We need to do a minus current one, right? And here we also do a minus, and then similarly here, this one. The last one is the multiply operators. So for the multiply operators, it's a little bit tricky because, like I said, we need to use the current values, subtract the previous one, and then plus the previous one times multiply the current one, right? And then so the current one will be this one. The previous one multiply the current one. That's going to be the new pre values. Yep. And then in the end, I think that's pretty much it is, right? Yeah, I think we can just run this one to see how it will go. Okay, accept it. Oh, I think I missed one thing here. Since we have this kind of branches here, which means that this one can go all the way to the end, right? So it means that we could have like one. Let's say we have one, 2, 3, 4, 5. Let's say for this one, so if we have a 1, 1 plus 2 plus 3, and then plus 4, 6, 5, and the target is 6. So if that's the case, since we have this one, we have this one always as one of the scenarios here. So if we use this one, or when we reach the index equals to n here, right? So the current value is 6, right? Because we only update the current values when we are at this kind of when we're at this part of code here. So which means that if we have this kind of evaluations here, so the values when we reach the end, so the index is the n, and the value is 6, but the current but the current equals to 4, 6, 5, right? Yeah, so that's why we have some invalid scenarios here. So that's why to handle that, we can simply add like another conditions here, in the final check here. So if this one is equal to target and the current is equal to 0, right? So that we're making sure that we have considered each number in this string here. So if I run the code again, so now this time it passed, right? Yep, I think that's it. So in terms of the time complexity, right? Since at each of the scenarios we have 3 options, right? So is it 3 options or 4 options? I think 3 options. So which means that we have n 3 to the power of n. That's gonna be the total time complexity for this problem. Yeah, where n is the length of the number. Cool. I think that's pretty much it is. I want to talk about for this problem. And yeah, thank you for watching this video, guys. Stay tuned, and I'll be seeing you guys soon. Bye bye.